In this video, we're going to go over the steps of how to find the value of a missing variable. Now, there are a couple things you want to remember when you're looking for a missing variable. The first of which is to check all of your terms and make sure that they're combined before solving. And what kind of goes along with this is that when you combine like terms, you can only combine constants with constants and coefficients with coefficients. So for example, if I had 6x plus 3x plus 2 equals 10 plus 3x plus 8. Again, we're not solving this, we're just combining the terms. I can only combine my x's with my x's and my constants, my just normal numbers by themselves, with themselves. So if I were to simplify this, I would say 6x plus 3x, well, that's 9x. And the 2, I can't combine anything with it on this side of the equation, so I just leave it alone. Over here, I can't combine my 10 with the 3x, but because 8 is also a constant, I can combine those two. So I might write 18 plus 3x, right? And then I would solve after this. Something else you have to keep in mind is to cancel a term, you have to use the opposite operation on both sides of your equation. So I'll show you a quick example. If we have 3x plus 5 equals 16, if I want to cancel this 5 and get it over here, I have to subtract by 5. So that would give me 3x equals 11. Whereas on this side, if I did 3x minus 5 equals 16, notice the difference between the addition here and the subtraction here. I wouldn't subtract by 5 on this side, I'd actually add on 5. Add by 5 on both sides. So I'd have 3x equaling 21 on this side. And again, we're not fully solving it, we're just showing you one step at a time. And make sure that you're moving all of your constants to one side and all of your coefficients to another. So I'm going to show you a quick example of some things I've been seeing in class. So I might see a problem that says 2x plus 8 equals 3x, let's say 12x. So 12x plus 8 equals 3x plus 4. And I'm seeing people cancel out everything on the left or everything on the right. So for example, they might cancel out 3x on both sides. Notice I'm only canceling out the x's by themselves. So I'll have 9x plus 8 plus 4, I'm sorry, equals 4, I should say. And then I'll see people subtract by 4 instead. They end up with something weird. They'll have 9x plus 8, I'm sorry, 9x 9x plus 4 equaling 0, and then this gets a little weird. When in reality, all you should be doing, is instead of subtracting by 4, you need to subtract by 8. That way you have two terms on both sides. You have 9x equaling negative 4, just as an example. Now, let's go through a couple of examples that we can talk with one another about. And I'm just going to leave these rules on the side over here. I'll clear all the work. So for this example, my first step is I want to get rid of all my constants on this side because I want my coefficient to be on this side. I'll subtract by 10 on both sides. I'll have 3x equaling 9. And then this is where I would divide because I'm multiplying here. 3 times x, I would actually divide by 3. X equals 3. Now on this side, I'll do this in green. Pretty similar problem. I did change the constant on the right side, but that's only to make sure that it makes sense. I would add by 10 on this side, plus 10 plus 10. So now I get 3x equals 21, because minus 10 plus 10 cancels out to be 0. This will give us 21. We still divide by 3 at the end. I get x equals 7 on this side. So be careful. If we're adding in order to get rid of it, we subtract. If we are subtracting, we add to get rid of that constant. Now, in this next example, we have a little bit more to deal with. And what I want to emphasize in this example is, again, you want to cancel the terms with opposite operators. And you also want to make sure that your constants and coefficients are on opposite sides. So I'm going to want my coefficients to be on my left side, so the v's are going to be on my left, and my constants are going to be on my right. I want them over here. So the first thing I'm going to do is I want to make sure that all my variables, all my constants are on my left side. So instead of subtracting by 3v, I'm actually going to add by 3v. That cancels this out. I'll add 3v over here, and I get 5v, and then I carry everything down. Plus 8 equals, if there's a minus 12 here, it's going to end up being negative 12. Now from here, I need to subtract by 8, because here we're adding it. So I subtract by 8 on both sides, and I'll have 5v equals negative 20, because negative 12 minus 8 is the same thing as saying negative 12 plus negative 8, which will give me negative 20. I divide both sides by 5. And watch out here because I do have a negative 20, so v is going to equal negative 4. Now, in our next example, we do have a distributive property problem. So these follow their own rules. The thing that's most important is you have to remember to distribute the outside value right here. So I'm going to multiply negative 4 times 3 and negative 8 times 3 as well. Negative 4 times negative 3 is going to give me negative 12c minus 24, and that equals 36. Now from here, I have a pretty similar problem, similar to the last ones we've had. As you see, we've got a simple linear equation. So what I want to do now is I'm going to want to add 24 to both sides. So this will cancel out because they're opposite operations. I have negative 12c equaling 60 now. And now I'm going to divide both sides by negative 12. And you'll see I get a value of c equaling negative 5. Now in this example, what I really want to concentrate on is combining your like terms properly and canceling terms with opposite operations. So the first thing I'm going to want to do is combine my like terms. Again, I only combine my m's with my m's. So I have 8m plus 10, and that equals, so we have leftover 10, that's where the 10 comes from, and I have 6 plus 3m minus 1. So I'm only going to want to look at my constants. So if I cover up this 3m, I only see it's 6 minus 1, that's 5. And then I need to include the leftover 3m, so plus 3m. Now this is where I use opposite operations to solve this problem. So here, what I'll be doing is I'm actually going to want all of my variables on my left side and all my constants on my right. It's totally up to you. If you want, you can do it the opposite way. You could have your variables on your right side and your constants on your left. So I'm going to subtract by 5 on both sides. 8m plus 5 equals 3m. And I'm going to get my variables on this side, on my right side actually this time. So I'm going to subtract by 8m. This cancels out. I also subtract by 8m here. I have 5 equals negative 5m. I'll divide by both sides by negative 5. So I get that negative 1 is equal to m. So again, you got to make sure that your variables and your constants are all in simplest form. And from there, you can start using opposite operations to solve your problem. If you have any questions, please let me know. As always, feel free to email me.